Hi everybody. In this video we're going to look at derivatives of logarithmic functions. Alright, so first of all, recall that exponential and logarithmic functions are inverses of each other. So this is very important, okay? Exponential and logarithmic functions are inverses of each other. So remember, we've already learned a rule for finding the derivative of an inverse function. So if f and g are inverses of each other, then g prime of x would equal 1 over f prime of g of x. Okay, we've learned that in the past. Okay, so let's now take that rule and apply it to natural log of x, and we'll find its derivative. Okay, so if f of x equals e to the x, and g of x equals natural log of x, which are inverses, then g prime of x would equal 1 over f prime of natural log of x. Well, remember, f of x is equal to e to the x, so that means f prime of x equals e to the x. We've already learned that derivative. Okay, so that means f prime of natural log of x would equal e to the natural log of x power. So this will be 1 over e to the natural log of x power. And again, because those are inverse functions, e to the natural log of x is just equal to x. So we get a new rule where the derivative of natural log of x is equal to 1 over the x power. Okay, so this you can add to your list of derivative rules. Okay, now, what about logarithms with other bases? Well, to find that derivative, we can use what's called the change of base formula. And change of base formula says if you have log base a of x, that is equal to natural log of x divided by natural log of a. Okay, so if we find the derivative of log base a of x, it would equal the derivative of natural log of x over natural log of a. Well, if we're finding the derivative with respect to x, then 1 over natural log of a is just a constant multiple. So we're using the constant multiple rule. And we're just going to put that in front, multiply it times the derivative of natural log of x, which we just learned previously is 1 over x. So this equals 1 over natural log of a times 1 over x, which eventually we would probably write as 1 over x times natural log of a. Okay. So if you have a base, a logarithm with a base other than e, okay, which would be natural log of x, then its derivative is 1 over x times natural log of a. Okay, so again, you can add that to your list of rules for derivatives. All right, but let's look at some examples of how we might use these rules. So here we want to find the derivative of 4 to the w power minus 5 times log base 9 of w. So to start out, we're just going to use our difference rule, and we're just going to find the derivative of each term. So the derivative of 4 to the w power is going to be 4 to the w power times the natural log of 4 minus, okay, 5 is a constant multiple, so I'm just going to bring that down and multiply it times the derivative of log base 9 of w, which is going to be 1 over w times the natural log of 9. And then to simplify this, there's not a whole lot of simplifying. I don't know, sometimes we might bring that natural log of 4 in front of the exponential function. I don't know, you probably might see it both ways. But here we could definitely multiply straight across and get 5 over w times the natural log of 9. Yeah, and that's okay. I would definitely just leave it there because from there we'd have to find a common denominator and things are just going to get more complicated. So, all right, next example, we have 3 times e to the x plus 10x cubed times natural log of x. Okay, so here we have to use the product rule. Okay, so f prime, we're going to start by finding the derivative of 3e to the x, which because 3 is a constant multiple, we can bring it down and multiply it times the derivative of e to the x, which is e to the x. Okay, plus, and now we're going to have to use product rule. So we'll have first times derivative of the second, derivative of natural log of x is 1 over x, plus second times derivative of the first, which is power rule, which is just 30x squared. Okay, so a little bit of simplifying. Not much we can do with 3e to the x, but here we could multiply straight across, and you would get 10x cubed divided by x, which would simplify to 10x squared, plus, and again, maybe put the 30x squared in front of natural log of x, just so it's not confusing. But other than that, you could factor out a 3 as a greatest common factor, but I think I would stop there. All right, our last example, this time we're going to have to use quotient rule because we have a quotient. Okay, so y prime is going to equal, we're going to start with flow d pi. Okay, so that derivative is going to be 5e to the x minus pi d low. So that derivative is going to be 3e to the x plus 0, because the derivative of 1 is 0. Okay, all over low squared. I'm actually looking at this wondering why it's even on here, because it's not even a logarithm, but that's okay. This was more like what we did in class today. So we can factor our numerator. Definitely noticing we can factor out a 5e to the x, and that would leave 3e to the x plus 1 minus 3e to the x, okay? Those are going to add to zeros, so you end up with 5e to the x times 1 over 3e to the x plus 1 squared, and then that'll just simplify to 5e to the x over 3e to the x plus 1 squared. Okay, so you guys, I want to add one more example with a logarithm. Let's say that your function is 5 times the natural log of 2x squared plus 3x minus 1, something like that. Okay, so to find this derivative, the function is a constant multiple, so we're going to move that down, and we're going to multiply it times the derivative of natural log of 2x squared plus 3x minus 1, which remember is going to start as 1 over what's in parentheses, so 1 over 2x squared plus 3x minus 1. So we're actually using chain rule here, okay? because our outside function is natural log of x, and our inside function is 2x squared plus 3x minus 1. So again, it kind of goes back to like the derivative of natural log of x equals 1 over x. But if it's ever natural log of anything more than x, you have to use chain rule. So it's always 1 over what's in parentheses, but then times the derivative of what's in parentheses. Okay? And then when you multiply straight across, you'll end up with 5 times 4x plus 3 over 2x squared plus 3x minus 1. And that's about all we can do there. So anyway, I just wanted to show you how chain rule would work with logarithmic functions. Okay, so we'll definitely practice this some more in class tomorrow. Thank you for watching. Have a good night.